All right. So number 33 says an ant climbs on a steady speed up a side of an anthill, which has an incline of 30 degrees from the vertical. Sketch a free body diagram of the ant. And you'll just have to bear with me because I don't have my protractor or ruler because I just didn't bring it home with me. So for that question there, you would have your little ant, okay? And it was climbing up the hill, and it said it was at a 60-degree angle, okay? And then, of course, you know, your force gravity is going to go down. So that is just a picture representation. But what I'm going to do now is I'm going to actually draw a free body diagram, okay? So when we did our free body diagrams before, we didn't do this, but we're going to start doing this now, where you have your x-axis and your y-axis, okay? And so here we have him going up the hill. We are also going to have a force normal. Remember, force normal is always parallel. And then we're going to have our force gravity that's going to go down this way. And then also, we're also going to have a force gravity coming down here. Now, this is your 1x. This is your 1y. This is your force normal. This is your force friction, your force gravity for your y-axis, because your y-axis is going in that direction. And then you're going to have your force gravity coming in this direction. And then we're going to put a dotted line here, and this is going to be for force gravity for your x position. This free body diagram looks a little bit different than what we've done before, because now we're going to do our x and our y-axis, and we're just including that in our little diagram, okay? So number 34 says, Ryan and Becca are moving in a folding table out of the sunlight. A cup of lemonade has a mass of 0.44 kilograms is on the table. Becca lifts her end of the table before Ryan does. As a result, the table makes an angle of 15 degrees with horizontal. Find the components of the cup. Sorry, guys. Find the components of the cup. Weight, parallel or perpendicular plane of the table. So, number 34, write this in your ISM book. You're going to have your force gravity, and it's going to be parallel, equals your force gravity, sine, and theta. And what we're doing is we're using that paper that we did yesterday or the day before. I think we did it on Monday. And so on that, we had our x, y, and we had our sine and our cosine. So we're basically using that, excuse me, while I cancel Red Cross from calling me for the 80th time today. Put it on silent. Now it won't bother us. And so what we're going to do is we're going to plug in our numbers. Now, it tells us that her mass, right, of the cup was 44 kilograms. We know that our gravity is 9.8 newtons per kilogram. And then we know that the angle of it was 15, and we're going to use sine. So what I'm doing is I'm using this equation right here. The force times gravity, sine, angle, okay? I'm going to try to see if my calculator will pull up. Are you still able to see my screen? Clayton?
Yes, ma'am. Yes, ma'am.
Thank you, guys. Appreciate that. So what I'm going to do is I'm going to show you how to do this, okay? So what you're going to do is you're going to, this is degree, right? So what we need to do first is we need to change our mode. So what you're going to do is you're going to go down here. Do you see how it says radiant? we need to change that to degree. So you click your calculator down to degree and you hit enter. If you don't put your degree in, it's not going to make the equation right. So we have open bracket, 0.44, close bracket, open bracket, 9.8, close bracket. And then we're going to do our sign, and we're going to do our 15, and we're going to do our close bracket. Now, I'm recording this so that if you're not able to look at your book, write it down on the paper, and do your calculator all at the same time. I'm doing it this way so that you can go back if you want to make sure you know how to put it in the calculator. So my calculator says that it's 1.1, and I know it's going to be newtons. So I'm going to go back to where I need to go, which is here. And I put 1.1 newtons. Now, that is the parallel section of that. But I also need to find the perpendicular. So I'm going to do force gravity, perpendicular, and that would be force gravity. And instead of sine this time, I'm going to use cosine. I'm doing the exact same thing I'm doing up here, except now I'm going to use the cosine button instead of the sine button. So that's going to be 0.44 kilograms, 9.8 newtons per kilogram, and then cosine 15 this time. So I'm going to open up my calculator. Ooh, I can put it right here beside it. Isn't that awesome? Didn't know it. So we can do an open bracket, 0.44, close my bracket, open my bracket, 9.8, close my bracket, but this time I'm going to use my cosine button instead, and I'm going to use 15 again, okay? And I'm going to close my bracket, and I'm going to hit enter. So the answer for that one I got is 4.16. I'm going to change that to 4.2 newtons, and this is my answer for number 34. Does anybody have any questions so far? Okay, 35. 35 says Fernando has a mass of 43 kilograms, slides down the banisters at his grandparents' house. If the banister makes an angle of 35 degrees with the horizontal, what is the normal force between Hernandez and the banister? So I'm going to use force normal, same thing again, mass times gravity, and this time I'm using cosine theta. Now, on your test, I'm going to tell you if it's sine or if it's cosine or what the formula is. You have to know what it's talking about, okay? So if you read this, it tells you his mass was 43 kilograms. What's his mass? Gravity is still 9.8 newtons per kilogram. And this time we're going to use cosine, and we're going to use 35. So, calculator, open up my bracket, 43, close bracket, open bracket, 9.8, close bracket, my cosine, and my 35, and my close bracket, and hit enter. And I got 345 newtons. So what that is that is question 33, 34, and 35 on page 139. Okay, I think that's fairly easy. And what we were doing is we were using this scenario here, this example problem here. And the only thing I did is I took this example problem, I took what they did, and I applied it to the questions down at the bottom. So now what we're going to do is we're going to turn to the next page. On the next page, what we have is we have another sample problem. And my suggestion to you for tomorrow is to make sure you've looked at these sample problems, because a lot of times on the test, it'll actually have a problem similar to the sample problem. So for this one right here, we're going to have to, they drew up the coordinate system. They read the question. They put in, well, mass is 45 kilograms. My sliding kinetic friction is 0.23. Time is 1 second. My angle is 27 because it tells me that's the slope. And it tells me that it started at 0. Okay. And it says starting from rest. We need to find the acceleration, velocity final, and then the angle of it when it gets finished. So they go through these steps here on trying to figure it out. The first thing they want to do is they want to find out what the angle is. So what they did is they took their 27 degrees and they did 270 plus 27. They got 270. If you look on your paper that you drew, it's going to tell you there's a 360 degree angle that we have there. And if you take that away from 20, you should have 270. And that's where they got the 297 from. I'll be giving you these information. And then what they did is they tried to find the Y direction and the X direction. As you can tell, for the Y direction, if you look on your paper, it'll tell you you need to use sine. And for your X direction, it will tell you that you need to use cosine. Okay. Then what they did is they just went through and then they find out the velocity final based on this information. So there are some steps that you have to go through. So let's go and look at question number 37 on page 141. The only thing I'm going to do is I'm going to go over 37, 38, and 39 with you here in class, and then you'll be free to go. And then when we do our test tomorrow, if you remember, we'll kind of do it all together as we go. Then we'll see what we need to have done. So it says, consider a crate on an incline with problem 5. So they're using problem 5. Problem 5 is in the page before, okay? Calculate the magnitude of acceleration after 4 seconds. How fast is the crate moving? So if we look, here is our sketch, okay? So if we had to sketch it, we would just sketch the same thing. The only thing I'm going to do, instead of sketching it all, I'm just going to write down what kind of math that we would need to do. The first thing we want to do is we're looking for acceleration. That is, of course, force divided by mass. So to be able to find force, we need to have force gravity, sine theta, over mass. So I'm taking this acceleration and I'm plugging in this. But in this scenario, if we look at the problem, they are using the mass instead of the force. So we're going to use this problem here, mg sine theta over m. This could have possibly been it. This possibly could be it. But we're going to be using that equation there. So we start with first. Since we're m cancels m, right? The only thing we have left is gravity, sine, and then the angle. Well, we know that it's 9.8 newtons per kilogram. We know that is telling us the angle is going to be 30 because that was based on the problem before. See, the angle was 30. So we're going to do sine 30. So I'm going to go over here. I'm going to open up. Well, I guess I'm going to turn it back on. I'm going to open my bracket up. I'm going to do 9.8 close bracket, and then I'm going to do sine, and I'm going to do 30. And I'm going to close my bracket, and I'm going to hit enter. So based on that, I got 4.9 meters per second squared. How do I know it's meters per second squared? Because I'm trying to find out what the speed of it is. The next thing that I'm going to do is I'm going to go and I'm going to try to find acceleration. To find acceleration, you have to take velocity final minus velocity initial over time final minus time initial. So we are going to let velocity initial equal time initial, which is going to be equal to 0. The reason I'm doing that for is because it says here that it is starting at a stop. So to be able to find my velocity final, that's the only thing else I need to do. I'm going to take acceleration times time final to get my answer. So here is my acceleration. So 4.9 meters per second squared, and I'm going to times that by 4.0 seconds, because in my equation up here, it says that it is 4 seconds long. So I'm going to take my calculator. I'm going to open up my bracket. I'm going to do 4.9. Close my bracket, open my bracket to 4 point, and I'm just going to do 4 point. That's the same thing as the zeros. And my answer is 19.6 meters per second squared. That is my answer for number 37. Now let's look at 38. It says George decided to try to slide discussed in example problem 6. That's this one over here. And it says George's trip down the slide is quite different from Enco's. After giving himself a push from the start, George slides at a constant speed. What is the coefficient of the kinetic friction between George's pants and the slide? So the first thing that I'm going to do is I have to remember how to find acceleration for friction. So that is G sine theta minus the sliding kinetic friction cosine of the angle. So if A is equal to O, and O is equal to gravity sine theta minus gravity of the sliding friction cosine of the angle. Sorry, guys. Then I know that my sliding friction has to equal sine 37 degrees divided by cosine 37 degrees. So based on that, if I did sine 37 and close my bracket, I got 0.60. And if I did sine 37 divided by cosine 37, it tells me my answer is 75. So my answer for this question is 75. One more question to go, and we're going to be done. Question number 38. Question number 39. It says that Stacy has a mass of 45 kilograms sliding down a slide that has an inclined angle of 45 degrees. With a horizontal, if the coefficient of kinetic friction between Stacy's shorts and the slide is 0.25, what is her acceleration? So for this one, what I'm going to do is I'm going to do gravity sine theta minus the coefficient of friction cosine of my angle. So for this one, I'm going to know some of the answers here. I know gravity is 9.8 newtons per kilogram. I also know that the angle that it says here, it says the angle is at 45 degrees. So I know that's 45. And I'm going to subtract that by what my kinetic friction is. It tells me that her kinetic friction, well, it doesn't give me the coefficient of kinetic friction. So then I'm gathering I need to go back to problem 6. On problem 6, it's telling me the kinetic friction is 23. But does that help me? No. But if I look back at the problem again, because I looked at the wrong one, it tells me that hers shorts, it is 0.25. So it does give me that. So it is 0.25 is my kinetic friction. And then I'm going to do cosine. And what is my angle? My angle, it says, is 45. Now I got to put everything into my computer. Now, if you see here, I have an open bracket, and then I have another bracket that goes out here, okay? So putting it in the calculator is kind of tricky. So let me show you how. So you open bracket with your 9.8, okay? And you're going to close your bracket. Now it's telling me to use a big bracket. So to be able to do that, you see above there, there's a blue sign. So if I do second, do you notice my bracket's different? So now I'm going to do sine 45, close it. I'm going to do subtraction, and that's 0.25. And I promise you, if you do it just like I have it written down, you'll get it right, okay? And then cosine 45. I'm closing my bracket. But now I need to close my outside bracket. So I'm going to do second here and enter. And I get 5.19, which I'm going to say it's 5.2. Now, the key to what you're doing here and what you're going to be doing in class is going to depend on, do you know how to use that online calculator? If you don't know how to use that online calculator, you're going to have a little bit of problem with the equation. Now, who has a question? Everybody's good? Okay.
Wait, though, I need that last question. I didn't finish.
Okay, I'm sorry. Let me go back and share that with you again.
Thank you.
You're welcome. Can you see it, baby?
Yes, ma'am.
Okay. Now, I promise you on the test, I'm going to give you an equation. We're going to talk about it. I'm going to give you the equation. But here's the problem that you're going to have. If you don't know how to put this in the calculator, it's not going to help you, is it? So make sure, and I promise you, I will help you as much as possible that you need help on that.
Thank you. I got it.
Okay, baby, I'm going to close this out and I'm going to stop the recording for you. I think I've already, let me see. There we go.